Hello, and welcome to a tutorial on how to use Zephir. We will be going through the steps to track new key points in a new dataset. For this tutorial, we will be tracking fluorescent neurons in this movie of a moving C. elegans worm. Notice that we have already done some pre-processing for Zephir in this movie. For the best results, we recommend that the general region of interest be centered with a fixed orientation, like how the worm is always facing left here. Once the data is ready, we need a way to actually access the data. We provide a set of I/O utility functions we call getters. These functions can be freely edited as long as the outcome is the same. Now, any new getters defined within the dataset directory will always be prioritized, so the best practice is to copy the file over and edit it here. We will include a link in the description if you'd like to learn more, but we will be sticking with the default functions for this tutorial. Before we can start tracking, Zephir needs at least one manually annotated reference frame. You can pick your own, or Zephir can recommend you a list of frames. The recommendation engine runs a k-medoids clustering algorithm to help you choose frames that will best represent any global spatial patterns in the video. Let's go ahead and fire up our annotator. Here's our data, which is three-dimensional, so we can switch between a slice view and a flattened view, which is a maximum intensity projection. It's a little hard to see our neurons right now, but we can adjust the scaling and the gamma on the pixel lookup table over here and get it nice and bright. Now let's take a look at our macros here. These are key-bound Python functions that can be really helpful for interacting with your data. You can pick a function out of the list here and list out your arguments here. This is the default configuration right now, which is just fine for making some annotations. So let's go ahead and make our first annotation. We can click where our first neuron is, starting in the flattened view. That gets us close in the horizontal plane. But remember to switch to slice view so we can get it in the right vertical position. You can use the blue sliders on the sides if you need to get the crosshairs just right. Now we can go ahead and use our macro insert annotations, and there we go. For our next annotation, we have to make a new track so we can distinguish one neuron from another. We can use the macro create track to do just that, and just follow the steps from before, like that. We can get it looking a little nicer just by coloring the tracks. If it starts to get a little cluttered, you can toggle the look of the annotations as well. And we just rinse and repeat for the rest of the frame. And always, 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 don't forget to save. Once we got our reference frames ready, we can go ahead and run Zephir. We can do that from terminal or command line. You may need to adjust some of the parameters to get the best results for your particular dataset. You can follow the link in the description to get a full list of parameters and some examples to get you started. All right, we got our first results. Not bad, but we could do better. Let's fire up our annotator again. We've picked out a sample frame here to look at. We can cycle through the different neurons and check if they were tracked correctly. Hard to see right now, so we can unfill the circles and just look at a single slice's worth of annotations instead. Notice how these annotations are tagged with the provenance ZEIR. This lets us know that it was a Zephir result, not a manual annotation. We can flip to a reference frame and back to check some of the results, and we can see that this neuron is looking pretty good. For good results, all we have to do is change the provenance, and it is now a manual annotation, and will be treated like one by Zephir too. But for a bad result like this one, we'll have to actually delete the old result and insert a new one at the right place. Oh, don't worry, you won't have to do this for every single bad result. We can actually rerun Zephir right here with the new annotations, and after a second or two, it will help fix other bad results, like how this one next to the one we just fixed also got fixed. For fixing entire frames, we recommend you select some key points scattered across the entire image, upgrading the good ones and fixing the bad ones. Running Zephir after that with restrict updates up to false should give you a much better fit than before for every key point in the frame. Once you're happy with the one frame, you can move on to the next, or try running with update children set to true. This will track every child frame downstream of this one, and any improvements to one of them will cascade all the way down. Rinse and repeat for each branch of frames, and that should get you to the finish line. For any of the steps we have gone through today, you should feel free to adapt as needed to develop a workflow that works for you. If you run into any issues, please submit an issue on GitHub or contact us. We're happy to work with you to get Zephir working for your datasets. Thank you for watching, and we wish you happy tracking.